The next basic concept we're going to talk about is the idea of units. So when we're describing things in chemistry, or any science for that matter, we need to have a set of units that defines what we're talking about. When we report a value, say I measure something and I measure it to be 2.5, that doesn't tell me 2.5 what, right? Is that 2.5 puppies? Is it 2.5 feet? Is it 2.5 glasses of water? And so units are a really important part of science. So maybe we went to a balance and we measured this is 2.5 grams of a substance. So this unit, this here, G, this stands for grams, and this is one of the system SI units that we have. So SI is a French term. This unit system was developed by French scientists, I think originally in the late 1700s, and then has been adopted in more recent times by scientists around the world. We've all agreed to go with this system of units and standardize it across the world. We still use the French name for it so that it's consistent. So I have that written out here. I do not speak French. I'll try to pronounce it. It's the Système International de Unités, but I speak Spanish, so that's probably why it sounds a little bit Spanish. Anyway, we just call them SI units to be, and don't worry about using the French name. So grams, for example, is the unit for mass. So if we're measuring masses, we can measure those in grams. Or there are different units. So we're familiar in the United States. We often use a different set of units that we call imperial units. So say we might measure something in pounds. That's not part of the SI system, so we don't use that. Or we might measure a distance in miles or in feet, right, if we're thinking about distance. And these are also not SI units. We can convert from these units to SI units, but if we want to do SI units, these are all going to be in terms of the meter, which we give the symbol M. So I'm going to scroll down here to what are the SI units. So there's a base set of units that we have that we start with. Let me make sure. Okay. So the base set of units that we use is here in table 1.2 from the textbook. And these are, everything else that we have is works off of this set of units that we have. So for mass, the unit of mass, that's the base unit, is in kilograms. So this one's a little weird. It's not the gram. You think it might be, but it's the kilogram. Length in meters. That's our base unit. Temperature is in Kelvin. We'll talk more about temperature. So some other common ones that are used are degrees Fahrenheit, degrees Celsius, but the base unit is Kelvin. Time in seconds. And these are the ones we'll use most often. We will not, in our class, I'm going to put parentheses around this, we won't use the unit of amperes very much. So this is a unit of electrical current. We will use the amount of substance unit, a mole, and we'll talk about that in a lot more detail in future chapters. And this is another one we will not use hardly ever. In fact, I think I've never used this unit personally because I don't need to, but luminous intensity in candelas. So you can basically ignore amperes and luminous intensity. Amperes and candelas, we won't really use those units. Though amperes are used in chemistry if we're talking about electrochemistry, where we're looking at chemistry to produce electricity and things like that. But for our purposes, we're mostly going to be focusing on units that are related to mass, length, temperature, time, and amount of substance. Now, we can combine these base units to make more complicated units. And we'll see those as they come up. So one relatively simple example is we can combine meters and seconds to get something in meters per second. So this is now a unit of speed, which is how far can you go in a second. You may be familiar with the more common in the United States, miles per hour. And you can convert between these two different units. We'll talk about unit conversions in the next video. The other thing we can do is use these prefixes that are in table 1.1 here that allow us to, let's pick blue, allow us to combine these with the base units, or even not just the base units, even things like other units that are made from the base units, to define things in terms of powers of 10. So let's say I do a measurement, 1.5 0.67 grams. We'll stick with grams. But in that one, grams makes perfect sense. But what if I measured something that was 1,255 grams? That's not too bad, but it might be easier to say, well, I measured something that's 1.25 kilograms. If we look down here, kilo is right here, has this K that goes before it, and what that means is that we multiply that unit by 1,000. So these are equal to each other. I should add one more 5 here. Right, so 1,255 grams is the same as 1.255 kilograms. That's a pretty trivial example, but say we're measuring something that's very, very large, something like the amount of bytes on a computer hard drive. And some of these hopefully look familiar from that. So say I have, let's see, 10 to the 12 bytes on a computer hard drive. That is a 1 terabyte hard drive. So if I have 1 times 10 to the 12 bytes, that is the same thing as 1 terabyte. Tera is given the symbol capital T. So if you're not already familiar with these units, I would encourage you to use these tables to get familiar with the prefixes that are used. We'll be using these a lot in class. Mostly focus on things between here and here. Most of these go by factors of power, 3 powers of 10. So our sort of regular unit just has nothing in front of it. And then if we go up by 1,000 times, we get to kilo. 1,000,000 times, we get to mega. 1,000,000,000 times, we get to giga. So each time we add 3 zeros. And same thing going down. If we have 1,000th, that is a milligram. 1,000,000th is a microgram. 1,000,000,000th is a nanogram, and et cetera, et cetera. And we have, for the powers of 1 and 2, we have some special ones here in the middle that are used less commonly but do show up. So in this section here, in particular, the one you'll see the most is centi. And you're probably already familiar with the centimeter. That's the way it shows up the most. So that's a 100th of a whatever. 100th of a meter for a centimeter. You can also have centigrams, but nobody uses that. So this is a brief introduction to the SI unit system, and is something for you to look at, to become familiar with if you're not already.